As you know, I'm a big fan of the good old number line, so now what I'm going to do is do a number line that shows the normal numbers between 1 and 10 and their corresponding logarithms, which will therefore run between 0 and 1. So here we've got normal number 1, and so the logarithm of 1 is the logarithm of 10 to the power 1. I hope you're in agreement. And therefore the logarithm, so anything, so that's 10 to the power 0. Yeah, so that's it. So anything, so 10 to the power 0 is 1, anything to the power 0 is 1, and so the logarithm is 0. Sorry for misspeaking there. And then here we've got the normal number is 10, and so the logarithm of 10 is the logarithm of 10 to the power 1. 10 to the power 1 is equal to 10. And so the logarithm is 1. So as I say, our logarithms run between 0 and 1, and our normal numbers will run between 1 and 10. So now let's look at some convenient numbers in between that. So how about 0.5, or so that's equal to 1/2. So that means that we're looking for the, we've got 10 to the power 1/2. So 10 to the power 1/2 is the square root of 10, and which is equal to 3.16 if I look it up in my calculator. So that is the logarithm of 3.16 is equal to, is the log of 0.5, 3.16. Now I'm just going to do the same for a couple more. So how about 1/3, or 0.333? So the cube root of 10 is 2.15 if I look it up in my calculator. So that means that the log of 10 to the power 1/3 is equal to the logarithm of 2.15. So the logarithm of 2.5 is 1/3. And finally, for 1/4, or 0.25, the fourth root of 10, if I look at that up in my calculator, I get 1.78. So the log of 10 to the power 1/4 is the log of 1.78, and so the log of 1.78 is 0.25. Okay, so now let's add these onto our number line. So this is meant to be even nice and evenly spaced here for the logarithms. Here are logarithms. So our log is 0.25, so that's here. And we know that the normal number that corresponds is 1.78. So we've got 0, the logarithm is 0, the normal number is 1, log is 1, normal number is 10, log is 0.25, normal number is 1.78. Similarly, if the log is 1/3, then the normal number is 2.15, and if the log is 1/2, then the normal number is 3.16. So you'll see that when the logarithms are evenly spread, then the normal numbers are not evenly spread. So from 1 to 1.78 takes up all this room, and then everything between 1.78 and 10 is going to be squashed here. Okay, so now let's add these guys. So here we've got the normal numbers on the left, logarithms on the right. So 0.301, so that's here. In fact, let's do these ones in green that are from the table. 0.301, and that is equal to 2. 0.477, normal number is 3. 0.602, normal number is 4. 0.699, normal number is 5. 0.788, normal number is 6. Logarithm is 0.845. Normal number is 7. Logarithm is 0.903. Normal number is 8. And finally 0.954. Normal number is 9. So as I said, all this is quite squashed up. The numbers that are approaching 10, whereas between like 1, 2, 3 are quite nicely spread out, but 7, 8, 9, 10 are quite squashed up. That's an interesting point we'll be coming back to when we discuss log linear graphs.